Every day, my company gets scam phishing emails trying to get money or sensitive info. I wanted to protect my employees and my clients, so I checked out CISA's Secure Our World. They've got simple ways we can protect our businesses from online threats. First, teach employees to recognize and report phishing. Next, require strong passwords plus multi-factor authentication. And finally, turn on automatic updates for your business software. To learn more, go to CISA at cisa.gov/Secure Our World.
With Kroger brand products from Baker's, you can make all your favorite things this holiday season. Because Kroger brand's proven quality products come at exceptionally low prices. And with a money-back quality guarantee, every dish is sure to be a favorite.
These are a few of my favorite things.
Whether you shop delivery, pickup, or in-store, Kroger brand has all your favorite things. Baker's, fresh for everyone.
Today's show is brought to you by ExpressVPN. Protect your online activity today and find out how you can get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Visit tryexpressvpn.com/space to learn more.
15 seconds. Guidance is internal. 10, 9, ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello, and thank you for joining us on episode 171 of the Space Nuts podcast. My name is Andrew Dunkley, and joining me, as always, astronomer at large, Professor Fred Watson. Hello, Fred.
Hey, fancy seeing you here, Andrew.
It seems, only a day or two since we spoke. Funny how time just is so
It melts
weird.
away. It just melts away, doesn't it? Yeah. Never mind, that's all right.
Now, let us go through the agenda for today, shall we? We've come across a watery new exoplanet, which sounds rather exciting because we've been looking for one of those. Because we have a planet that's in the Goldilocks zone where liquid water exists and thus life. And so the school of thought is if we can find another one, maybe that's got life too. Well, they've found one, but it doesn't sound like a very nice place. We'll just put it at that point. We've also got a story about a massive explosion that seems to have occurred at some time in our galaxy's history. This is an explosion that's resulted in sort of 2 radio bubbles that have been discovered at our central core. And what caused it is the subject of much deliberation and speculation, but maybe it's got something to do with the black hole, maybe not. And we're going to answer a few questions. Somebody's piped one in about the Juno mission and asked if future probes to Jupiter might use Jupiter's radiation as a source of power rather than relying on solar panels to get energy from a distant sun. That is a great question. And we're going to tackle, it's sort of a question. It's something that someone experienced some years ago. Lloyd Galbraith from Cairns in North Queensland nearly broke his toe on a rock some years ago, and now he thinks it was a special rock. He drew a happy face on it and everything, I reckon. So we'll find out what that rock might be. And a simple question, and I must say that the author of this question was a little embarrassed, Fred, but it is actually a brilliant question to sort of get us back to basics about the universe. Why does everything spin? So we'll tackle all of those in this episode of Space Nuts. But let's start off with this incredible find. They're already labelling it Earth 2, a watery planet, an exoplanet that seems to be in the right place in orbit of its star.
Yes, that's right. This planet, which rejoices in the delightful name of K2-18b, and the 2 tells you it's from what was called the K2 mission, which was the Kepler spacecraft engaging in further searches of stars once its gyroscopes had given up, so it could only point in certain directions. So this story is about the discovery of a planet which is about 110 light years away. So kind of not really on our doorstep, but nevertheless of great interest. And what's been discovered? First of all, the discovery of the planet itself, which I think was about 4 years ago, with the Kepler-2 mission, and that tells you that the planet is about twice the diameter of the Earth, because you can detect that when a planet passes in front of its parent star. If you know how big the parent star is, and we do know generically about the diameters of stars of different types, you know how big the parent star is, you know how much its light dims when a planet wanders in front of it, and by combining those two, you can work out the diameter of the planet, which is, as I said, it's about about twice the diameter of the Earth, which, and it turns out from other measurements that it's got about 8 times the mass of the Earth, and those two figures suggest that it's probably rocky.
Okay.
That's the the outcome of that, rather than being a gas giant.
But that's an interesting anomaly. It's twice the diameter of Earth and 8 times the mass. Is that normal?
Yeah, because if it's the same material of the Earth, 2 cubed is 8, and it's
So
the cube.
you're getting into a realm that really troubled me at school. So, okay,
It's quite all right. Things like that troubled me too. So it's bigger than the Earth, and that, of course, means it's got a higher level of gravity than the Earth has. It would not be a pleasant place to walk
so
on.
you'd probably be much heavier.
You would indeed. Your weight would be much greater. But the reason why this is an exciting finding, and why it's getting quite a bit of media attention, is that there have been follow-up observations made with the Hubble Space Telescope, looking at the way the atmosphere of this planet impacts the light of the star when the planet passes in front of the star. So this is a trick we've talked about before. You look for the change in the spectrum of the star when the planet is in front of it, because what the atmosphere of the planet does is puts its own fingerprint on the rainbow colours of the spectrum of the star, and that well-known barcode of information that you get is modified by the atmosphere of the planet. And that's how the scientists know that there's water vapor there. It's I actually read the Nature paper because I was asked to comment a couple of times on this, Nature being the journal in which this research has been published. And the modelling that they've had to do to make this discovery is quite significant, but certainly the graphs and the data which I saw, they do support the conclusion that these authors come to, that there is water vapor in the atmosphere of the star.
Now that's
the atmosphere of the planet.
Quite excited, because now they're thinking, all right, water vapor in the atmosphere, maybe lakes and rivers, maybe oceans.
Yes, that's right. Maybe a temperate world. There are some, I think the temperature range, I think the lowest part of it is a bit debatable, but by that I mean the lower limit of the temperature range, possibly 0, possibly below 0 Celsius, with a probable maximum of about 46 degrees Celsius.
Geez, that's sounding very much like where I live.
Actually, now I've just remembered something I read when I read the paper itself, which I think it put the lower end of the range as 200 degrees Kelvin. Now, 200 degrees Kelvin is minus 73 degrees Celsius, so
that sucks.
it could be well below 0. But that makes it similar to Mars. Mars is that kind of temperature, and we know there's liquid water on Mars underneath its south pole, and probably occasionally there's liquid water elsewhere. Mars, on the other hand, has no water vapor in its atmosphere whatsoever, at least not detectable. It is there, but in minute quantities. Yeah. Whereas this object, K2-18b, does have, because it's been detected. Now, in terms of its habitability, One of the problems with this place, apart from its increased mass, which means that humans wouldn't really be able to survive there, one of its perhaps even bigger problems is that the kind of star it orbits, which is called in the trade an M-dwarf star, is known to have fairly violent outbursts, solar flares of a much more intense kind than we experience on the sun. And so that puts the planet in a radiation environment that is probably not particularly amenable to life. It may even be, that it is just too highly, the radiation is just too high for there to be any living organisms on the planet. We simply don't know that. This kind of study is still in its infancy, and so as time goes on, we'll with bigger instruments, the James Webb Space Telescope and things like that, we'll probably know more about that.
So given its mass, given its parent star, given its temperature range, life would struggle there as we know it. And perhaps it's not a candidate to be an Earth 2. I mean, it's probably the best thing we've found so far in terms of a liquid water planet in a Goldilocks zone. But it sounds like it's got a hostile host as a star, as a sun, and a few other things going against it. So we might have to keep looking, Fred.
Indeed. So it's probably Earth 1.3 or something like that, being Earth 2. But yes, we will have to keep looking. It probably won't be at this particular planet, though. I mean, it will be once we get the bigger telescopes, but sending a spacecraft there is not really on the cards. I did a quick sum that says that with the fastest spacecraft we've ever launched, it would take 1.5 million years to get there, and most of us lose interest in that kind of timescale.
Yeah, and it'd be pretty boring, and I mean, you'd need to probably replace your pack of cards several times over while you're travelling. They'd wear out. But it's again the vastness of distance and time that really cripples us in all our endeavours. We're probably victims of our own success in many ways when it comes to astronomy, because we're finding these things and going, isn't this exciting? Except we can never go there, and we never really will find out. So
exactly,
that's the hard
part.
But
as I said, with the Kepler Space Telescope, sorry, I beg your pardon, the James Webb Space Telescope, the successor to Hubble, which has a 6.5 metre diameter mirror, and then with the coming generation of ground-based extremely large telescopes, we will find out a lot more about these objects.
That'll be the exciting part. Will we maybe be able to detect, maybe not detect life, but detect the elements that would almost confirm the probability?
Yes. So what you're talking about are things we call biomarkers.
That's
that's
too big a word for me.
BIO. So in other words, the signature of biological byproducts in the atmosphere of a planet, and they include things like oxygen out of balance with carbon dioxide and methane out of balance with other things. The kinds of, the astrobiologists have got fairly well-defined signatures that living organisms might put into an atmosphere. It's not actually as neat and tidy a topic as, you'd like it to be, but there is certainly a lot of work on this being done, actually by one person who used to work at our observatory, the Australian Astronomical Observatory, Vicky Meadows. I think she's at, I can't remember which institute she's at, but she's certainly been a very high-profile figure in NASA's astrobiology effort. So the Aussies are contributing to this as well.
Very good. All right. Well, maybe not this planet, but I'm thinking very soon we may well find an Earth 2.0 that is in exactly the right place, is exactly the right size, next to exactly the same star as ours, or one similar, or just right. And that could be a candidate for future investigation. Who knows? You're listening to Space Nuts with Andrew Dunkley and Fred Watson. Now, let's take a little break and find out more about our sponsor, ExpressVPN, rated #1 by Tech Radar. This is the one I use. I've been using it for a couple of years and I love it. When I joined ExpressVPN, they were brand new to the market, but I read a lot of reviews and did a lot of comparisons. And there was just something about their business model that I particularly liked. And a couple of years down the track, honestly, can't complain. Their interface is very easy to use. Their service is second to none. I've had to contact them a couple of times about certain things that I wanted to do, and they were brilliant. So you may be wondering why I do need a VPN at all. It's all about privacy. Do you really want big tech companies, governments and others knowing what's going on with your online activity? Even if you're having nothing to hide, it just feels downright creepy. I think you'll agree. And governments are getting more and more interested in what you're doing every day. And so, yeah, protecting your privacy is what VPN is all about. And how often do you run across websites that you want to get information from only to find that they're geo-blocked? This is becoming an increasing problem, but ExpressVPN solves that problem for you. Now, if you go to our special URL, you'll see quite a list of things this service can help you with, things you may never have thought of before. As I say, it's the one I use, secure, fast, and it just works. So protect yourself online today and find out more about how to get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Try expressvpn.com/space to learn more, and you'll find the link details in the show notes and on our website. Now, back to the show.
0G, and I feel fine.
Space Nuts.
Now, Fred, to a discovery a little closer to home. This is a discovery that's just been published simply because where we were looking, we weren't able to see until now. But thanks to a rather beautifully named telescope, which we've talked about before, we have now been able to have a look at the central regions of our galaxy. And what they've discovered is that something cataclysmic happened there, resulting in these radio bubbles, I think they're calling them. This all sounds very, very weird, but also very exciting.
Indeed it is. And it's the first... I guess the first really significant result from the complete Meerkat. And Meerkat is the name of this telescope. It's a radio telescope array in South Africa. We have talked about its name before because CAT is an abbreviation for the Karoo Array Telescope. And then when the South African government said, oh, you can have a few more dishes in that, they called it Moorkat in English, which in Afrikaans is Meerkat, which is a very nice little segue to those little mongoose-like things that you see in the
as I speak, there are probably a dozen of them about 2 kilometres from where I sit.
In the Western Plains Zoo.
We have them at the zoo. I love them.
Right.
They're so cute.
Yeah, they're very cute. Just to wave the flag a little bit as well, Meerkat, of course, is a kind of parallel to Australia's ASCAP, the Australian Square Kilometre Array Pathfinder, which is out in Western Australia. ASCAP also has a large number of dishes. It's 36, but Meerkat is bigger in terms of its number of dishes, although the dishes themselves are smaller. It's got 64. And the difference between these two parts, which are still part of the preparations for the Square Kilometre Array, the difference between them is that the Australian dishes look essentially at low frequencies, radio frequencies. The Meerkat dishes look at what you might call mid radio frequencies. So they're kind of looking at the same universe, but in slightly different ways, and that makes them very complementary. So, to the story.
Yes.
These 64 antennas of the Meerkat array have mapped the central region of our Milky Way galaxy. So what they've done is look towards the galactic center, which is in the constellation of Sagittarius, and regions around that. The mapping has taken place, and they've been looking specifically at these radio frequencies. Now, when you do that with a radio telescope, you see all these bright blobs and things like supernova remnants, which are the results of exploding stars. They show up very brightly. And there are also regions where new stars are being born, which show up very brightly in the radio. That's what you find in the Milky Way. But what these investigators have found, and I think this work is being led by a team based both in Oxford and in Cape Town. What this work has found is something that almost looks like an hourglass. These two bright radio lobes as above and below the plane of the Milky Way, centered really towards the galactic center. So if you imagine the Milky Way is this, beautiful disk of stars and gas and dust, and we're embedded in it, which is why we see the Milky Way. The Milky Way galaxy also has this supermassive black hole at the center. I think it's, if I remember rightly, 4.1 million solar masses. It's about 4 million solar masses, which from time to time engages with its surroundings in a fairly explosive way. And that is what these astronomers think is the source of this kind of hourglass shape. So, with one bubble above the plane of the Milky Way and the other bubble below it, perfectly symmetrical, the center of the Milky Way galaxy right in the middle. And the suggestion is that something big has been swallowed up by the black hole at the center of our galaxy, probably a few million years ago, and that's sort of basically sent out this gigantic cosmic burp, which has given rise to these radio signals as it runs into what we call the interstellar medium. So there's a gas comes out at relativistic velocities, collides with the medium around it, the rarefied gas that populates our galaxy, and basically sculpts this cavity that is very bright. Well, it's not very bright, but it is bright in radio emission. Saying very bright is actually a misleading thing to say, which is why I've just retracted it, because these guys had to work really hard to see this, among all the other brilliance of the radio sky near the galactic center.
Yeah, in fact, that's the problem with the galactic center. It's very difficult to observe because there's so much junk lying around in there.
There is, yeah. It's the densest part of the Milky Way galaxy, and exactly, it's full of junk, if we can put it that way. It's just a train wreck, really, when you look at it.
Yes.
And actually, one of the lead authors from Cape Town, Professor Camillo, I think is the way that his name is pronounced, he says finding this was like finding a tiny firefly in the presence of a bright torch. And maybe I could just read a quote from him. The bubbles are actually one big bubble structure stretched out with two lobes at the polar ends. They were created during the same event. From top to bottom, the structure is 1,400 light years. The bubbles are 25,000 light years away from the Earth, which is the distance to the galactic center.
Now, I did read the article, and I must confess I got a little bit.
With Kroger brand products from Bakers, you can make all your favorite things this holiday season. Because Kroger brand's proven quality products come at exceptionally low prices. And with a money-back quality guarantee, every dish is sure to be a favorite.
These are a few of my favorite things.
Whether you shop delivery, pickup, or in-store, Kroger brand has all your favorite things. Bakers, fresh for everyone.
Sort of mesmerised by it and lost my way and found myself not understanding certain aspects of the discovery. But one of the things that I thought I read in the article about it was that one day we might be able to observe this explosion. Does that mean the light hasn't reached us yet?
Oh, that's interesting. I haven't seen anything suggesting anything like that. No, in fact,
I got very confused.
Yeah, the light would have arrived at basically 25,000 years after the event took place, but that was all several million years ago. It does tie in, though, Andrew, with some work that was done I guess it's about 3 years ago, by a colleague of ours here in Sydney. His name is Professor Joss Bland Hawthorne. He's at the University of Sydney, somebody I've known for a very long time, and he's one of the nearest things I know to a genius is Joss, because he's full of ideas.
I found the piece that I was referring to.
Okay.
In effect, this inflated energetic bubbles in the hot ionized gas near the galactic center, energizing it and generating radio waves, which could eventually be detected here on Earth. So,
which is what
radio. Yeah.
So that's what we've seen. Yes, that's
right.
Yeah,
okay.
Yeah.
There you go.
Just going back to Joss, he and his colleagues observed there's a thing called the Magellanic Stream, which is a cloud of gas that links our galaxy with the two Magellanic Clouds, which are two dwarf galaxies that are effectively being gobbled up by our own galaxy. And there's this stream of radio emission between the two, and it's more or less above the center of our own galaxy. And Joss and his colleagues detected a brightness in the radio emission from the Magellanic Stream, which suggested that at some time in the past it had been energized by what sounds like the same event. It may have been exactly the same event that we're talking about now.
Okay.
This bubble of radiation blew out of the galactic center and lit up the Magellanic Stream, so we can see its evidence there as well. Or it could be an entirely separate event. I'm just speculating here, but that's that's the kind of thing that radio astronomers are looking at.
As for what was the cause, as for what the black hole engulfed or whatever it is that happened, we don't know.
No, it's probably, it could well be a sort of almost like a feeding frenzy of the black hole, because black holes are known to sort of flare up from time to time as they consume the dust and gas around them. And maybe it's just that it was a particularly dense blob of gas that found its way into the black hole and produced maybe not just one but several powerful outbursts. We see evidence of this when we look into the distant universe, because there you're looking way back in the past when black holes were a lot more voracious than they are now. And what you find are what we call quasars, and quasars are exactly this. They're black holes that have gone ballistic because they've got so much stuff to consume. They're growing rapidly. They're also generating intense magnetic fields which are shooting up jets to the north and south from their poles, and causing great brilliance at very great distances, which is what we now call quasars. So, it's a phenomenon. The point I was going to make was that doesn't happen in today's universe because there's not enough debris lying around for them to do that. So, our own galaxy probably was a quasar 4 or 5 billion years ago, but it's settled down since then. But occasionally there might still be bursts of activity like the one perhaps a few million years ago that caused this phenomenon.
Okay, very interesting.
Hopefully
more to learn from that too. We will wait and see. You're listening to the Space Nuts podcast with Fred Watson and Andrew Dunkley.
Okay, we checked all 4 systems and keying with a go.
Space Nuts.
Once again, want to send a big thank you to our patrons who are growing in numbers, and that is fabulous. If you would like to become a patron of the Space Nuts podcast, you're welcome to do so. It's not mandatory. It is a voluntary thing. You can do it at patreon.com/spacenuts. There are different tiers of support, and you can find out more about it by going to the site and reading up on it. And if it's not for you, that's fine. Patreon.com/spacenuts if you would like to sign up as a patron. And don't forget, you can chat to other Space Nuts people, Space Nuts, I think we call them, at the Space Nuts Facebook page. So just do a search for the Space Nuts Facebook group in your Facebook search engine, and you should be able to find it. And put your name down to join up, and meet other people. They're talking to each other, Fred, fairly regularly now. The latest thing is comparing telescopes, which
that's good.
It's actually quite fascinating. And when they start getting into the techno speak, I sit there and go, It's really, really, really good. So lots to do online while we're not around. And, we do appreciate your ongoing support. Now, some questions. We'll go to this first one from Michael Johnson. Michael Johnson? Yeah, Michael Johnson. Who has an interesting backstory, which I will mention. Dear Fred and Andrew, love your podcasts. I always try to catch up with the latest episodes on my way back home from my harp gigs while on country tour. On the subject of the Juno mission, I'm fascinated by the amount of radiation that Jupiter emitted. That Juno had to avoid its orbits around the gas giant without actually flying directly through the radiation belts about Jupiter. Would it be possible for future probes to harness some of the radiation to power the probe's electronics rather than having to rely on solar panels? It seems logical that the biggest power source would be right there near Jupiter compared to the conversion of light from a distant sun. Looking forward to your reply, Michael Johnson. Now, Michael is the resident harpist and composer with the Royal Botanic Gardens in Sydney. That is awesome. We're getting some classy people listen to us, Fred. I'm feeling a little bit outranked now, but it's good to have you along, Michael. Thanks for the question, and it's a good question. That is, obviously there's power there. Why do we need to sort of still rely on the sun when we're right next to something much more powerful at that position in space?
Well, it's a good question. And greetings, Michael. And you probably know some of the people I know in the world of harp, classical harpism, like Alice Giles and other harpists that I've had the pleasure of working with from time to time.
He does throw in a PS. Enjoyed your blues song on your website. You're never going to escape that.
No, I know. That's all right. That's fair enough. If I'm going to be known for something, it might as well be the blues. But look, what a great question. And in fact, Juno is interesting because that was the first mission to Jupiter that did use solar panels rather than an RTG, a radioisotope thermoelectric generator. Perhaps just to illustrate that, the Pioneers and the Voyagers and the Galileos all used RTGs, but Juno boasts these, what I think are the largest solar panels ever launched into space. I might not quite be right because the International Space Station has got colossal ones, but anyway, they are big. Why didn't they use an RTG with Juno? Two things. One, solar panel technology had come of age, so that the 4% of what we receive, which is what Jupiter receives in terms of sunlight, was enough to power the spacecraft. And the other thing is that the plutonium isotope that's used in the radioisotope thermoelectric generators is getting more and more rare. It's actually more expensive, and it turned out that it was cheaper to build the solar panels, which is in many ways the bottom line. So that might go to the heart of the answer to this question, which is, we see those radiation belts as very, very dangerous. They have the tendency to fry electronics rather than make themselves useful. And that's exactly why, as Michael has said, that the orbit of Juno is highly elongated. It's so that the spacecraft spends most of its time on the outside of these radiation belts and ducks underneath them for a short time near the surface of the planet, or near the top of the cloud layers of the planet, and then ducks out again to avoid its electronics being fried. I'm not sufficiently well versed as an electrical engineer to know whether you could ever harness that energy that's in the radiation belts. But I think the bottom line is likely to be that such technology, if it exists, might very well be more expensive to implement than simply good old solar panels, which are now at a level of sensitivity that actually make them a viable alternative.
Yeah, cheap as chips these days, and of course with the battery systems that are available, you can just keep recharging them, and it's and it relatively lightweight too, I suppose, in the scheme of things. But very, very efficient, and the new technology in solar panels is they're incredibly efficient when you get to the high end versions of the product. So it does make sense, and they're easier to point in the right direction too, I suppose. So there's all sorts of benefits to solar panels. But yeah, maybe one day we will need to look at other options, or maybe find a cheaper alternative that does the job. So it's a question worth asking. Yeah. Michael, thank you for that. And I do want to see if I can find you online and listen to you on the harp. I just think it's an amazing instrument. I'm always mesmerised by it when people play it so beautifully. Now, let's move on to a question from Lloyd Galbraith in Cairns, North Queensland. Hi, Lloyd. He says, back in the 70s, when he was about 10, he was walking through the bush just south of Sydney and kicked a rock that damn near broke his toe. He said he picked it up and even then could tell it was no ordinary rock. It seemed twice as heavy as it should have been. So he carried it home and he's had it ever since. Now, he says, I've always thought it could have been a meteorite or something like that. It is black. It never rusts. It gets a black powder carbon-like surface. Heavy as hell, but does not attract a magnet. One of my kids dropped it some years ago and broke it into bits. And inside it is still black through, even though it had silver-type flakes inside. Now, some 47 years later, I'd really like to know what it is. I've done some home-based tests, and to be honest, nothing I've done's really confirmed or not if it is or isn't a meteorite. So what do you think? What's he found?
I don't know.
He's found coal.
I don't think it's a meteorite, though, because meteorites generally, well, certainly the metal ones, the iron and nickel meteorites, they are very obviously metallic, and as Lloyd kind of hints, they do have magnetism. You can stick a magnet on one and it'll stick very hard, because it's the iron, it's soft iron, and essentially a bit of nickel in there that is what makes the metal meteorites. And when you drop them, they tend not to break. They usually break the floor instead, because they're very solid and quite dense, being lumps of iron. They also have a bit of a sort of giveaway, in the sense that their surfaces are usually pitted, because as they fly through the atmosphere, the surface gets very hot and it ablates, it burns away, and it leaves little pits behind, which they've got smoothed edges, but once you've seen one, you kind of recognize this pitted appearance. The stony meteorites are normally much lighter in weight and much lighter in color. They're sort of beige rather than this metallic color that an iron meteorite would be. But they too have the pitted surface on the outside. This sounds like something different, because it's clearly got a surface that powderizes. It gets a black powder carbon-like surface on the. Sorry, it gets a black powder carbon-like on the surface, heavy as hell, which that suggests a metal meteorite, but I suspect it's something else. I wonder whether it could be a phenomenon, a product of different geological phenomena, possibly even volcanic in origin. But the bottom line is that Lloyd's asking where to send it while he's still alive.
To that, but,
and I know that feeling myself. Oh, I must do something about this while I'm still alive. Well, it's a bit of a problem in Cairns. The kinds of places who would certainly be able to give you information about whether it was meteoritic would be the Australian Museum in Sydney or the University of Western Australia in Perth, because they've got probably the best collection of meteorites in the country. So they've got every kind of variety of meteorites and would certainly know about its origin. But that might not be very convenient.
you might be able to just send a piece of it.
Well, but yes, that's right.
Seeing the
It's
kids broke it.
possible. Since the kids broke it into bits, that in itself makes me wonder whether it is meteoritic, because meteorites are usually much more firmly stuck together than that. And as I said, if it's an iron one, you drop it and it breaks the concrete or the floor that you've landed on.
I'm sticking with the coal theory in that case.
You think it's a bit of coal? Well,
Could be coal.
yeah.
Why not? Although coal tends to be a bit brittle too, so
It does, yeah, and it's usually yeah. I mean, I used to deal with coal a lot because
not heavy.
when I was a kid, we had coal everywhere. It's not that heavy, and it's clear that it's got a obviously shiny surface that it actually looks like petrified wood almost, which is effectively what it is. Yeah, interesting. Sorry, Lloyd, I can't be any more specific than that. I do apologise.
but the probability is not a meteorite.
I will guess, yes.
Yeah. All right, Lloyd, thank you, and I hope you're enjoying sunny Cairns up there in the tropics. Cyclone Central. Sorry about that. Now, let's move on to our final question, and this one came in only like yesterday or today, but I'm throwing it in there because for two reasons. It's a question that obviously came to mind in that it seems so simple, and he's a little embarrassed asking the question, but I think it's a great question because it gets us back to basics. He says, "Hey, Fred and Andrew, this seems like such a simple question, and maybe it is, but why do planets spin in the first place? I understand that gravity attracts the planets around the sun, but what caused the planets themselves to start spinning? I know stars and planets are formed in clouds of gas and dust, which are constantly in motion, but I imagine Fred can probably explain it in a better way. Been a keen listener for 2 months now and listened to 165 episodes. Gee, Miles, get a job." No, I'm kidding. Thank you so much for making my job so much better. He listens while he's at work. So
he has got a job.
he has got a job, yes.
Thanks, Miles. It is a good question, and it's kind of goes to the heart of what we know about the solar system. And actually, Miles has already put his finger on it in the sentence that says, "I know stars and planets are formed in clouds of gas and dust, which are constantly in motion." And that's exactly what's happening. So you've got a cloud of dust and gas, and it's kind of swirling around. What tends to happen is that you find little eddies of almost like air currents within the cloud of gas. And these are going in all sorts of random directions, and they're all over the gas cloud. But over time, what's happening to this gas cloud is that and dust as well, is that it's collapsing under its own gravity. So it starts to collapse. And as it does, you get of all this mishmash of rotating eddies within the gas cloud, there emerges from that a preferred direction of rotation. And so the gas and dust cloud itself begins to rotate. And that is what we see. It's the fossil of that rotation that we see in the sun, the planets, the way they spin, the direction in which they spin. Virtually all of them spin anti-clockwise, as seen from above the solar system's north pole. That includes the sun as well. And that's the direction in which the planets revolve around the sun. So that it all comes from the rotation of the dust and gas cloud itself. So as that collapse took place, the central regions got very dense and eventually turned into the sun, a baby star, because the density, the compression was sufficient to raise the temperature so that you got nuclear fusion taking place. And the dust and other gaseous debris around it flattened down into a disk, which once again carried the rotation of the gas cloud with it. And it's within that disk that the planets formed. So once again, this direction of spin is a fossilized version of the way the original gas cloud was spinning.
Okay, fascinating. So I would have thought that it was just a symptom of the Big Bang and we're just spinning because of the outward blast that continues to this day. But obviously, yeah, there's a lot more at play. And there are some things in the universe that don't spin the way everything else does, but that's probably because of an intervention, and I guess Neptune would be an example of that.
It's Uranus, that's
Uranus.
Right. On it, which is kind of on its side. In fact, it's its north pole is slightly below its, the plane of its orbit. So you could say it's upside down because it's nearer to being upside down than right way up.
Exactly. All right, Miles, thanks for the question. It was a really good one. Appreciate you putting it forward. And we appreciate everybody who puts their thoughts forward for the Space Nuts podcast, whether that's between each other now on the Facebook podcast group or to us directly through our website, bitez.com/space nuts. That's the best place to post your questions, but people have been posting them on Facebook as well. That's fine. But keep them coming. We'll try and get to as many as we can. We seem to be bumping off fewer than arrive, but sometimes people ask questions we've already answered, and we'll let you know if that's the case. And that's about it for another week, Fred. Thank you so much.
It's a great pleasure, Andrew, and I hope we'll talk again in a week's time.
I hope so too. Catch you soon.
Yeah.
Professor Fred Watson, astronomer at large, and thank you again for supporting our podcast. We'll talk to you again real soon on Space Nuts.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Subscribe to the full podcast on iTunes and Stitcher or your favourite podcast distributor.
This has been another quality podcast production from Bytes.com.
With Kroger brand products from Baker's, you can make all your favorite things this holiday season. Because Kroger brand's proven quality products come at exceptionally low prices. And with a money-back quality guarantee, every dish is sure to be a favorite.
These are a few of my favorite things.
Whether you shop delivery, pickup, or in-store, Kroger brand has all your favorite things. Baker's, fresh for everyone.